Right, Gary's terrific trick. So we're going to do this actually kind of quickly because I want to give you guys lots of time to practice Gary's terrific trick. This is just a method for factoring when A is not 1. So if I have a problem like this, right, I could try to factor by thinking up what goes in each set of parentheses, right? It's possible. We did that 2 weeks ago now, a week and a half ago, before you guys went to 100 out. But instead, I'm going to show you a method that will always work, as long as the problem is factored in. So step 1 is that you multiply A times C. So what is A in this problem? 2. And what is C? 6. What's 2 times 6? Okay. Now that I've got this A times C figured out, I'm going to look for factors of that. So we're finding factors of A times C that add up to B. So this step is really similar to how we factored when A did equal 1. I'm going to look for factors of 12 that add up to 7. 4 and 3. But here's the key difference. Those are not like just going to give me the answer. I'm not just going to write x plus 4 and x plus 3. Instead, I'm going to rewrite this problem using these two factors that I found. Okay, so step 3, rewrite the problem breaking B up into the 2 terms you found in step 2. So it sounds kind of weird when we say it in words. We're going to rewrite the problem, breaking up B into 2 terms that we found in step 2. All we're doing is I'm writing the exact same thing, except that instead of 7x, I'm going to write 4x plus 3x. Or the other way around. It actually doesn't matter which way.
Wait, does that delete the 2x? No.
So this is the same. 2x squared is the same. Then I'm going to write 4x and 3x, and the 6 is the same. So I'm just looking back to my very first problem, and I'm simply writing, instead of 7x, 4x plus 3x. That's the same thing, wouldn't you agree?
Yeah.
4x plus 3x is 7x. So I'm not changing the problem. What I am doing is creating a way to factor it. Because now that I have 4 terms, how do you think I'm going to factor this?
Factoring by grouping.
Yeah, so step 4, we're going to factor by grouping, which we already learned, right? Group that, which means grouping the first 2 terms and the last 2 terms. What could I pull out of the first 2 terms? 2x, leaving 2x times x would give me 2x squared. 2x times 2. Good. Plus, in the second half, what can I pull out? 3. And what's left in the parentheses? Step 5, final step. Factor out the blob. Factor out the blob. What's our blob? X plus 2 And what do I have left after I factored that out? And I could check to make sure this works. I would FOIL it, right? X times 2x. 2x squared. Beautiful. X times 3. 3x. Well, that's not quite 7x. But then I also have 2 times 2x, which is 4x. 3x and 4x makes the 7x. And then I've got 2 times 3, which makes the 6. Yeah, and as you pointed out, the 4x and the 3x are those two terms that I broke it up into. Right? All right, we're going to do 2 more examples. Can I erase this one?
Yeah.
All right. Let's write out this example. So we've got 3x squared plus 11x plus 10. All right. Step 1. What's step 1?
You make it
multiply A and C.
So 3 times 10 is?
30.
Can anyone think of factors of 30 that add up to 11?
Yeah, 5 and 6.
5 and 6. That's step 2. Step 3, rewrite the problem. 3x squared doesn't change. The 11x does change. What am I going to write instead?
5x.
5x
And then
and
6x.
Yeah, I'm going to do it this way. It doesn't actually matter, but and the 10 stays the same. The reason I did it this way is I just see that 3 and 6 have something in common and 5 and 10 have something in common.
Oh, yeah.
And I like being able to pull it out.
Yeah.
It doesn't matter. If I didn't do it that way, I would still end up with the same thing in the end. But no, I just personal preference, really. It's like whether you want to pull the thing out or whether you want to leave it behind. Yeah.
I have a question. Does it matter where you put the 6.5?
Like if you put the 5 first, it doesn't matter.
Okay.
Not at all. So, yeah, I put it this way because the 6 and 3 have 3 in common. But if I didn't do it, I would get the exact same answer in the end. Yeah. It would just be like what my blob is going to be doing it this way would be what's left doing it the other way. And the blob the other way is going to be what's left doing it this way. So it like switches around which one of the factors is the blob.
On the first, factor out 3x.
Yeah, yep. Okay, so factor by grouping. In the first group, very good. We're going to factor out 3x times
X plus 2.
x plus 2 plus
5.
5 times x plus 2.
So it'd be 3x.
Right? I'm just going to check this really quick. 3x times x is 3x squared. 3x times 2 gives me the 6x. 5 times x gives me the 5x. 5 times 2 gives me the 10. Okay? And step 5, factor out the blob. X plus 2, 3x plus 5. So if I had done it the other way, if I had switched the 6 and the 5, in here would have been 3x plus 5. And then I would have had x and 2. Okay? Questions on that one? So we have to do one more example because we haven't used any negatives yet. Now I've got a negative. So what happens when I multiply a times c? What do I get?
Negative 60.
Negative 60. So I'm trying to think of factors of negative 60 that add up to 17. What do I know about those factors? One is going to be negative and one is going to be positive, right? So what are some factors of negative 60 that add up to 17? Negative 60 and 1 would be negative 59. 20 and 3. Wait, that equals 23. 20 and negative 3. 20 and negative 3. Okay. So I have a really strong preference for how you rewrite these. Again, it doesn't actually matter, but this one, in this case, it's going to make your life a lot easier if you write the negative first, always.
Wait, and all problems have one negative, right?
In all problems that have one negative, yeah, you would write it first. And you'll see why, okay? The reason is, as I rewrite this problem, if you think about like when I group, I've already got the negatives in the right spot, right? Like I've got a negative here and a negative here. If I put the negative here, what ends up happening is you have to pull out the negative, and that means you have to remember to switch this sign, which I think you guys would remember that, but it's just easier if you just, if you just get in the habit of, I'm going to write the negative first. That's basically just placing my negatives right where I want them, right from the beginning. All right, factor this by grouping. What does 6x squared and negative 3x have in common? You can pull out a 3x, leaving
2x minus 2.
No, minus x.
minus just a 1, right? Because 3x times minus 1 would be minus 3x. And then what can I pull out of the second two? 10, leaving
10 leaves 2x minus 1.
2x minus 1. Factor out my blob, which is 2x minus 1. And what do I have left?
3x plus 9.
3x. Alright, I just want to do something really quickly. This is Gary's terrific trick. When do we use Gary's terrific trick?
When the chemistry symbol.
When we have, right here, when we have something other than 1, right? How would you factor this? How would you factor this? Yeah, so what would we do? Factors of 12 that add up to 7 are 3 and 4. And then what?
And then it would be x plus 3x plus 4.
Then we're done, right?
Yeah, whoa, that was easy.
Because we don't have anything in front of x squared. I always see people, every single time, after we learn Gary's terrific trick, they'll go, oh, 3 and 4. So, okay, so I do x squared plus 3x plus 4x plus 12. This will work. You'll get the right answer, but you're going to do like 3 extra steps.
Also,
Yeah.
the way you
Right.
the way you would get there is, wouldn't you, if you remembered it properly, then wouldn't you try to multiply just 1 and 12?
Right.
And that should remind you, like, oh, I didn't need to.
Usually people don't do that stuff. They just, once they get the 3 and 4, because you're going to get so used to, oh, 3 and 4, rewrite the 7, right?
Yeah.
But it's like, if you don't have anything in front of x squared, that's just your answer,
Yeah.
right? You're just done at that point. So Gary's terrific trick is only when we've got a number right here, right? Other than 1. And even then, you don't have to use it. I mean, when I learned to factor, no one ever taught me this trick. I never knew it. So I would just have to think of what the two factors were.
Wait,
Right.
did Gary make it up?
Gary didn't make it up. He actually, I think he actually renamed it now, because he used to teach it as Gary's terrific trick, but I think he now calls it like, whoever taught it to him, it's like Jose's terrific trick or something. But it's like he wanted to give credit to the person who taught it. Anyway, I give credit to Gary because he taught it to me.